Okay, so we can start. Hello and welcome everyone. Today we will talk about quite unique thing and really futuristic industry, which is in fact the space mining. Today we will talk about building the whole value chain and how being involved in this industry can impact all kind of challenges which we have currently on the Earth. And in this discussion, we will talk with multiple companies which are involved in the separate parts of the whole value chain. Remotely, there are Michał Zachara from KP Labs, Alice Miller from Project Helios, while on site we'll have some guests. The first one is Mateusz Józefowicz from the European Space Foundation, which is part of the. Yeah, that's right. Well, you need to go to the scene. Which is a member of the Moderators consortium. We have Dariusz Marciniak from ING-PN, which is also the member of the consortium. From the iSpace, we have Dorian Legger. And we'll start our discussion. So I think that we can sit like most of our guests remotely. And we'll start with the short introduction. What your company do, how it is involved in the space mining industry, and what are the greatest projects about which you would like to talk to our audience, and as well we would like also to show how this space mining industry that it's not a fairy tale, that it's the real business which can support in multiple challenges which we have in our on Earth industries. So, Alice, would you like to start?
Yes, happily. Hello, everybody. I'm Anna from company Helios from Israel. And we have developed some technology to produce oxygen out of regolith, lunar soil. We deeply believe that this is going to be a main driver for the space industry in the future. As we all know today, you leave Earth, you go up into Leo. No matter what rocket you go with, you reach there empty. You cannot carry on. It's very hard leaving the gravity well of Earth, the thick atmosphere of Earth, and once Leo, we are empty. And at least in SpaceX, the plan right now is to reach Leo and wait over there and bring up small pieces of payload up of oxygen so that the Starship can carry on to the moon and to Mars and anywhere it wants to go. Our business plan is to put up a plant that will produce oxygen on the lunar surface and to supply that oxygen to customers on the lunar surface, in low lunar orbit, and in low Earth orbit too.
Great, thanks,
Yes.
Alice. Michał,
So that's what we do.
Right.
Yeah.
Yeah, thank you. And Michał, would you like to tell us about KP Labs and about your projects and how your solutions, your products can be used in multiple environments and multiple industries?
Yeah, sure. First of all, I barely heard Alice, so I'm not sure if it's only my connection or is the.
I think that we heard Alice very well, so possibly
Okay.
It might be something with connection.
All right, so thank you for hosting me here. My name is Michał Zachara, and I'm CEO of KP Labs. It's a Polish space company, and our main focus is onboard data processing. So we are delivering hardware, software, and AI algorithms to move the whole computation from the ground to space, basically. And we are doing it on the various levels. So first of all, we are focusing on low Earth orbit, and this is our core business. So we are delivering small computers for the satellites. But the next steps for the company development is to develop the data centers and the data processors for the lunar purposes. And for that reason, we are working with ESA on some projects. This is, from my perspective, kind of challenges that our company will face in the next couple of years. So we are moving from the globe to the deep space, and it's fascinating.
Yeah, thanks, Michał. And well, now it's time for iSpace. So Dorian, well, could you share us, well, introduction about yourself and about the projects which iSpace is running?
Sure. Thank you very much, and hi everybody. So iSpace is a global lunar exploration company, and we're based in Japan. We're about 200 employees now, and we have offices in the United States and in Europe. I'm personally based in the Europe office, which is in Luxembourg. And our vision is to expand our planet, expand our future. So by that I mean that we want to connect the Earth and the Moon into one connected ecosystem. So more concretely, what that means is that we're aiming to build a moon valley by the year 2040, where people will be able to live and work on the moon permanently. And so the question is, how do we get there? How do we make that happen? Currently, today, the big challenge is to actually get on the moon. There's only government landers. They're very infrequent missions, and they're very costly. So the first step is to develop a commercial solution with more frequent missions that are more affordable. So for the last about 10 years, that's what iSpace has been focused on. We've been developing landers and rovers. And beyond the transportation platforms, we're also working very hard to build partnerships in the attempt to collect all the talent and technology from companies, from different organizations, governments, and individuals in order to make this Moon Valley happen, basically.
Right. Thanks. Now it's time for the question, well, to the MicroRes consortium. As well, we have two members of this consortium. And, well, Dariusz is from ING PAN. So, well, could you tell us more about, well, also the MicroRes project from this, well, scientific perspective? Because I think it's also worth mentioning that in this industry, we talk about really strong connection between science and B2B sector.
Yes. We, as as an Institute of Geological Sciences in Polish Academy of Sciences, provide a knowledge to create mirrors, so multiplanetary far infrared or spectrometer, able to detect the spectra of precious minerals and with precious metals inside, like sulfides or oxides on the planetary or Earth surface. And during this, we cooperate with companies, and we cooperate also with business side during this project. And we, as an institute, like creating a need because we know that which sulfides and which oxides can be detected on the surface of selected celestial bodies.
Thanks, Dariusz. And Mateusz, well, could you tell us something more about, well, European Space Foundation and, well, how it's involved into, well, MicroRes project?
Yes, thank you. So, European Space Foundation is actually the organizer of the European Rover Challenge. So we've started basically with animating the communities that will be performing the projects and who will be making the things happen. But we are recently also starting involvements into specific R&D projects. And our role is basically to merge R&D with business, with the commercial side. So we are doing the business development in MicroRes, and we are doing the networking. And actually, Darek said about the need. So there is this creation of certain scientific value. We try to translate this value into solid package that can be delivered to the next stage of the value chain. So we are coordinating our part of the value chain and encouraging partners to join and to create value chains specifically for under mirrorless technology for sulfides and oxides. These are the minerals that actually contain a lot of useful elements. So this is about oxygen, but this is also about metals like titanium and iron, and also helium-3, because it's being absorbed by ilmenite on the moon, and we are able to indirectly map it with the use of the mirrorless device, which is also built together with another institution, which is Space Research Center of the Polish Academy of Science. And we also have an SME on board, so this is SKA Polska. So we are as a foundation, but also an SME. So there is a quite complex and flexible structure of the consortium.
Great, thanks. Well, as we can see, we have companies and institutions working well in different parts of the whole value chain. And I think that, well, I have the next question, and it will be to Michał. So could you tell us more about, well, the biggest challenges and opportunities which you see in this, well, lunar market, well, from the engineering and business perspective, as we see about, well, quite young market?
Well, so basically, thank you for the question. And basically, I think the biggest challenges are right now with the scaling up. So I think when we were setting up the company, it was back in 2016. We were in that position when we were observing the new space market, and it was quite fascinating because we changed the completely direction from sending a couple of satellites per year to thousands of satellites. And thanks to the companies as, for example, iSpace, we are observing this kind of change in the lunar market as well. So because of the SpaceX, the price of the deployment of the satellite is cheaper and cheaper with each rocket, and with companies as iSpace, I believe that the deployment of the cargo to the lunar surface would be cheaper as well. So from our perspective, it's a emerging market, and more companies as well as universities will be able to afford for that kind of the travel, and the business itself on the lunar surface. And from our perspective as a company, what we are doing, we are dealing with data. We are currently a society of data, and the company or the university or the institution that can deal with data has right now the advantage. So it's all about collecting the data and trying to work with that, because there is so much of data right now that it's quite hard to process. So from our perspective, it will work the same on the lunar surface. So there will be more and more rovers, more and more landers, more and more payloads for the mineralogy for 3D mapping, etc. And you will need to collect this data and later on to process it. And it's waste of time to send it to the Earth to do the processing. It's better to do it over there. So this is the challenge that we are foreseeing. And from our perspective, the biggest challenge in that market would be, technological challenge. So right now, I think surviving the lunar night would be the biggest challenge for the industries, because we are trying to downscale the rovers, the landers, but you need to remember about 100 degrees on the lunar surface, and you need to survive with your electronics. So you cannot downscale your rover up to some limitations, because you need to hit it. So I believe there will be a lot of nice changes on the both sides technology. The market itself as a global market will emerge, and I think that the third one will be the law. So that political part is still a little bit messy, so you don't know for now to whom the acquired regulator, for example, belongs to. So I think those all connections of technology, laws, and political aspects would be the biggest challenges in the future.
Great, thanks, Michał. And well, as you mentioned, harsh environment, I think that the next question will be to Dorian. Well, what kind of challenges do you observe in your, daily job and in the projects which are running in the iSpace?
So in terms of challenges, the first one that comes to mind is landing. It's quite a difficult task to actually land safely with all the payloads still functional. but then more connected to mining. I think that the mass of the excavators and the rovers that we're planning to send to the moon, that a lot of people are planning to send to the moon, need to be minimized. The mass needs to be minimized, but that creates challenges when we're dealing with excavation, because we can't create very good traction forces to be able to actually push regolith or to be able to lift it and transport it. So that's quite an interesting challenge on the sort of physics standpoint. It's also very relevant when we're talking about drilling. How do we actually create enough downward force with a mobile drilling platform? Another challenge is data. As was just mentioned, I think right now, in terms of ground truth, there's been about 400 kilograms of lunar soil that's been returned to Earth. But the lunar surface is something like 38 million kilometers squared. So we're talking about a surface area the size of Asia and ground truth the size of a barrel. And we're trying to extrapolate all this mineralogical information from such a small sample. So there's a big need for more ground truth data. There's also a big need for more orbital data. And yeah, going back to this question of power also, right now it's quite difficult to provide enough power and energy storage on the rovers. So on a 14-day mission, the rovers actually spend a lot of time sleeping so that they can recharge their batteries. And when you think about the economics of a mission, depending on the downtime and the uptime, that really has a huge impact. So it's very important that we increase the uptime of the rovers. And then connected to that, lunar night survival is clearly the big challenge that the industry is now trying to tackle, so that we can extend our missions beyond the 14-day horizon.
Right, thanks. And Alice, and well, we talked about challenges, and could you tell us more about, well, dual use of this technology? And I think that Project Helios is a great, well, it's example of the company which develops the technology for both mining on Earth and for, well, lunar mining.
Yeah, well, I can really relate to everything that has been said. You know, if we are going to put up a plant on the surface of the moon, we need to be able to go a very long way. You know, we have to be able to run our company for the next 20 years without income. And I challenge, you know, it's one of the biggest challenges of all these companies that are doing things that have got to do with the future business on the moon. And we were very, very lucky. We were doing experiments in our core, and we came to a result which was illogical. We found that we got more metals left over in the oven than the regolith we put into the oven. And that was kind of unexplainable. And we did it again and again and again. We got the same results. Every time we got more metal than we thought that we had in the regolith itself. So what we did was we took the whole oven apart, and we found that the oven itself was breaking down into oxygen and metal. And we came to a conclusion that if we can produce oxygen, have a byproduct which is metals, maybe we can produce metals and have a byproduct which is oxygen. So we went to ThyssenKrupp in Germany. We sat with them and we said, okay, guys, tell us where we've gone wrong, because how come for the last hundreds of years or thousands of years, metal or iron has been produced by bringing coal and oxygen together, creating CO2, and that's how you produce the iron. And we're saying, no, we have a new technology in which we can release only oxygen, cut down the energy costs by 50%. And they said that if this is true, if the technology we have come upon is actually working, we are going to change the whole metal industry all over Earth. And we have found a technology that can actually produce iron without emitting any carbon dioxide. And what is happening in our company now is that we're being funded by the biggest mining companies on Earth who are all interested in producing green iron. And this is how we are actually going to fund our 20-year endeavor of building an oxygen factory on the moon, which is quite amazing. I think, to be able to be a space company, it is impossible to survive this journey without a solid terrestrial business. Otherwise, the only way to do it is to rely on, governmental funding and going very, very small, very, very slowly. But what we're doing in Israel is we're building a plant, oxygen production plant in Israel, which is going to simulate what we're going to do on in the moon, but quite a large scale. Not kilograms of oxygen. We're talking about tons and tons of oxygen per month, and that is very expensive as everybody can imagine. And the way we're going to do it is by using the funding from the metal to fund this factory.
Great, thanks, Alice. I think
Yeah.
it's a great success story. And now I have a question, to the Mirrorless consortium, regarding building the solution which can be both used on Earth and directly on the lunar surface. Do you have any opinions about it, and also how your project also meets these requirements or standards?
Yes, I certainly agree that in order to survive, you need to have the Earth. You need to stand with one leg on the Earth, even if you want to do the step into into space. And indeed, Mirrorless is looking for the solutions to provide this. It's a commercial enterprise. It's not a scientific, purely scientific enterprise. It's commercial because this is the model that's gonna be dominating in the next decades, and is gonna be dominating on the moon certainly. We have similar thoughts to you, Alice, but we do not have our technology does not produce. We are prospectors basically. So what we can do is actually to provide our geological and similar services to earth mining companies, which is already a tough market. Unless you have some innovative solutions, we are developing this far infrared spectrometer. This is the first of its kind, because the sulfides and oxides actually show the spectral features in the far infrared range. But the trick is that it doesn't work on Earth because of the water content. So it's really well adapted for space, especially for the moon and Mars. And on the Earth, we can use it in arid areas or in polar areas at lower altitudes. So we are developing a service on a drone to speed up prospection and to make a living on earth mining consulting. We would like to engage with mining companies who really want to go to space along. So really finding those investors and companies which do not want to stay only on the earth mining is the key. If you have a company that is willing to talk about going to space, that's the halfway of success. But on the other hand, we hope that data will provide us a bit shorter path, because if we are talking about orbital data, they are gonna be the first product of the mining effort. So you need to do prospection first. This is what you do in order to land and to excavate. You really need to confirm that you are landing in the fertile spot. So this is when we come in, the pathfinders, and we commercialize the data. So actually, even before a machine or a man touches the surface of the moon again, we are able to generate a product that is already commercial, because you need to know where the fertile spots are. This is basically prospecting. And this is really nice that we are talking about data processing, because I think that we are gonna be producing a lot of data. So computers are really also a key that are able to work and pre-process stuff in let's say lunar orbit. It's the key. So really finding interfaces between partners, it's another key.
Right. And Michał, what is your vision, well, of the dual use of the technology on which you are working on, and in which industries do you think, well, your technology can be used in the future, or which sectors of the on-Earth on the on-Earth markets, well, can take advantage of the technology on which you are working, and well, it's developed for space, in fact.
Oh, well, so our products are not so, if I understand the dual use concept correctly, not the dual use between the military and the private markets, but the dual use between the commercial markets here on the globe and in space. Our products are rather space targeted. And from our perspective, well, we are focusing on delivering the computers that are reliable and can work in a very harsh environment. So they are having the quite high radiation protection. They've got very limited power consumption. They've got powerful processors. But when we are talking about the global applications, well, you've got big server houses when you can put whatever you want. So we are caring about space. We are caring about downsizing of our computers. And I believe that the space market is the only one that we are targeting right now.
Great, thanks. And Alice, from your perspective and perspective of the Helios, how can we support such initiatives, such projects, and where do you see areas to cooperate, well, between the space mining companies and, well, mining companies on Earth? Well, do you see some areas in which we can cooperate and we can boost the development of the technology?
Yeah, we've seen it during our current funding round that actually terrestrial companies are getting interested in what's going on the moon. It's not a space company that is going to space. It's actually a terrestrial company that has the funding, has the know-how, has the experience, has the knowledge, and they're getting interested in the moon because actually, there's such a long value chain for business on the moon. Even if we manage to put functioning oxygen factory on the moon, as per our roadmap in 2034, if there's no energy on the moon, if there's no rover digging up the regolith, if there are no conveyor belts, if there is no company there liquidizing our oxygen, storing our oxygen, sending it to the launch pad for the clients, a rocket to launch the oxygen into space, it's not going to work. And this is a very, very long value chain. So I think that what we need right now is we need to all align our roadmaps together so that we can reach our objectives. And I think that big companies on Earth who are used to operating large-scale mining businesses, mining projects, are very natural candidates to up on the moon. And I think it's coming together now. I mean, the terrestrial mining companies are seeing the possibilities on the moon and opening space divisions.
Right. Well, it sounds very interesting, and well, I think that it's the next question to the Dorian. Well, regarding areas in which we can support such projects, and in which categories of different actions we can boost the development of the technology.
Yeah, so let me explain a little bit about what iSpace is doing so that I can address where we can all fit in together. So iSpace right now is really focused on its first 3 missions. We call them M1, M2, and M3. M1 is a lander that will be taking off actually in November and arriving on the moon early next year. That lander has been assembled in Germany. It's now moving towards a test facility, and it'll be shipped to Florida later this year. That lander will be carrying a few rovers, some government rovers like JAXA rover and also a rover from the United Arab Emirates. So it's really an international group of companies and organizations that have come together, and also some private companies. After M1, we have an M2 mission, which will be flying in 2024. And what's really notable about the M2 mission is that it's carrying a rover that was designed by iSpace in Europe, and it'll be actually carrying some customer payloads. So that's what the iSpace Europe office is really focused on right now. And then for M3, so recently the NASA CP12 contract was awarded to Team Draper to fly scientific instruments to the far side of the moon. And iSpace was really proud and happy to be contributing to Team Draper by designing the lander for that mission. And so we'll be bringing the lander to the far side of the moon and also carrying some scientific equipment. So we have quite a few challenges where we're looking for help with partners. When we talk about value chains are giant endeavors, as Alice just mentioned, and there's so many interfaces between different companies. Not one company will not do everything for sure. If we look at, for example, the oxygen production value chain that I'm a little bit more familiar with, so it goes from prospecting, then excavation, possibly transport of regolith to a beneficiation station, beneficiation to upgrade the ore, then the ore will be passed to, there's multiple different technologies here, but for example, hydrogen reduction, so high temperature reaction to get water out, then an electrolyzer, then a liquefaction step, then storage, and then there needs to be an end customer somewhere. So we need help on every step of this value chain, and the technology needs to mature on every step of the value chain. In my opinion, I think beneficiation is one of the areas that has comparatively the least amount of research. So probably because it's one of the hardest to actually replicate the conditions on Earth. It's very difficult to, do a lot of experiments with short parabolic flights of what Earth-like, moon-like conditions could be. So, yeah, in terms of how can people contribute, I think there's clearly a lot of capability in Poland. This European Rover Challenge is a good example of how competitions like this can actually focus in and help to spur the technology development for, in this case, mobility or excavation. And more initiatives like this will go a long way in developing the technology that's needed for the production of value chains on the moon.
Right, yeah. So now I have the question, to Mateusz, I think, that about this business side, because later we'll talk with Darek about how we can support this, research stage, which is in most cases, the first one. So, Mateusz, would you like to tell us how we can support, building such projects and how it can improve our, economic growth, in fact?
Yes, so there's been some talking already at this conference about the questions of the current problems that we have on Earth, and really basic questions asked by audience who is not really involved in space, but wants to know what is it all about. That should we really be spending extra or large amounts of money for such science fiction, apparent science fiction topics like space mining? Yes, indeed, there are some keys to our well-being on Earth that lie in space, actually. So it's not only about building another outpost and the resources needed for that, but also the fuels of the future can be extracted in space, and the energy transformation is also really closely linked to capabilities that space brings. We can talk about helium-3, which is a popular fuel for the future nuclear fusion, which doesn't work on industrial scale yet, but it's probably the future of the energy on Earth, but also about orbital solar plants which can transfer the beam down the energy down to Earth efficiently. For that, you need to produce infrastructure in space. So, really, in space production based on the local space resources is necessary. And actually, one of the parts of the value chains that we've already managed to integrate is creating non-silicon technology of creating non-silicon photovoltaic panels that can be actually created out of the sulfides. So we have a partner that is developing this technology, very keen on finding another element of the chain, so the processing, then the client at the end. So it's really a puzzle. You need to really put the puzzle together, and you've got a very efficient structure that does not only sustain itself in space but brings direct benefits to Earth. The trick is to convince investors and people on Earth that it is worth investing. So it's not a traditional investment. When you see the return in 3 to 5 years, you really have to be patient, but the returns will be big. That's one thing, and another thing, it's a necessary step. It's really a step that has to be made in order to for humanity to find new ways of adapting, especially in turbulent times. So yes, definitely, it's time to invest into this.
Right, and Dariusz, how can we support such projects in this research stage?
In the research stage, we need engineers from Space Research Center from Polish Academy of Sciences, which prepared a setup and optical system. We as a geologist prepared experiments to obtain the spectra of the selected minerals important from our point of view, and we need time, and we need a cooperation between these two institutions to prepare such an spectrometer. And how to support?
It might be a kind of even philosophical question. How we can support directly
Yes.
the whole project. I have the next question, which is I think the most philosophical question, and it's always asked during any kind of discussion about space mining. So why should we do space mining? And what is your opinion about this thing? Dorian, would you like to share with us your opinion?
Sure. Broadly, I think that space holds tremendous opportunity. As people have observed, we're sort of a speck of dust in a massive cosmos, and so of course we're going to go there at some point. And the space economy is completely dependent on ISRU. We cannot carry basic materials out of Earth's deep gravity well to support the space economy. So there is a strong need for developing space resources if we want to venture out into the solar system and beyond. Another effect that this will have is that it will probably reduce the amount of rocket launches that need to leave Earth to space. So we won't be carrying, fuel, as Alice just said. We will be carrying more precious cargo, things that are hard to make in space. So scientific payloads, people maybe. Yes, I also wanted to touch a little bit on the dual use topic. So the European Rover competition, I think it's very interesting because it's showing a lot of autonomy and remote control of rovers. And from what I understand, the mining industry is actually extremely interested in this type of technology right now. For mine shafts or deep sea mining, For a lot of applications where the safety of workers is at stake, having remote controlled and autonomous vehicles can really improve, let's say, the KPIs of these companies. So I think that in terms of how to approach mining companies, it could be a good idea to show them that there is R&D value of developing this kind of technology, irregardless of the moon. And on top of that, they actually can go apply this to the moon, which is the next step for humanity. So that's a dual use that I'm quite interested in and is well connected to this event. And there's a few other dual uses that I find interesting in the context of mining. On Earth, we use a lot of wet processes in mining. For drilling, a lot of water is used. For beneficiation, a lot of water is used. So in iron production, a lot of there's a flotation technology which consumes a lot of water, and often this is done in areas that are actually water stressed. Australia, South Africa. So dry techniques are already known, but it's possible that in the context of space, we'll drive this innovation, drive this technology that will come down to Earth. Yeah, so I think dry beneficiation could be an interesting dual-use technology as well. Yeah.
Great, thanks. And Alice, well, from your perspective, why should we work on space mining?
Well, I feel space mining is it comes out of the inevitable want of human beings to explore. If we want to, we pick up our eyes at night to this beautiful sky above us, see these dots of stars in the sky, and we have the capability now to do it. We have the capability to get out of Earth and see what goes on out there. This capability didn't exist for the last billions of years. And people, and I know it is quite known that we have a very small window to make this happen. It's not going to be here forever, and now is the time. The ISRU is supporting the human endeavor of going out there. The ISRU is not a target in its own. The target is to explore and to see what is out there, see how it can benefit Earth. And that is disregarding all the natural benefits we are going to get on Earth, because everything is so expensive in getting out of Earth. It's like $1 million a kilo on the moon today, Dorian, right? Maybe a bit more. That is very expensive. Yeah. Anyway, to do that, we are not going to go to the moon and make a factory like you see on Earth with smoke coming out of the chimney and just releasing things to the environment. We're going to bring them back into the factory and produce something useful to sell. And doing all of this, we are actually going to benefit industry on Earth in a very big way, because doing things which are not zero waste on the moon is not very beneficial. So I think all these technologies that we are going to develop for our zero waste industry on the moon are going to come straight back to us and benefit us back on Earth. But I think that, if you see just imagine you see a river and on the other side there's a jungle, and says, we have no idea what's out there, but don't go there. What's the first thing you want to do? You want to go. And it's something like this. You look up at the sky, you see these stars, you hear the numbers, 100 billion stars in the Milky Way, billions and billions of galaxies. What is the story out there? We have to get there. We have to see it. We have to understand what's going on there. And ISRU is a real fundamental part of making this exploration possible.
Well, very interesting. And Michał, well, what is your opinion about reasons why, well, we should work on the space-related projects?
Well, basically, I believe that right now we are at Columbuses of the new ages, so we are discovering the undiscovered things beside the Earth globe. So first of all, it's a new economy to move forward as a humanity to work on the moon, to work on the Martian surface, etc. But I believe as a human race, we are just constructed in such a weird way that we are a little bit too curious to stay in one place. So we need to explore and we need to find the new uh, the new spaces, the new lands, and coming back to the Earth and maybe thinking a little bit more commercially. I think in the next couple, maybe not next couple, but in the next couple of decades, the Earth economy will be just exhausted in case of the minerals, in terms of the um, resources that are available here. So we need to explore, and I believe it won't happen that we'll explore, for example, the lunar surface and come back with the regolith here back on Earth in the next couple of decades. But it will be a next step to move forward. So it will be a stopover for the later missions, for example, to Mars. This is something I believe Dorian mentioned. So I think it's not about questioning why we should do it. It's rather questioning why we shouldn't do it. And I believe there is one simple answer: we cannot stop, and we need to explore.
Right, and well, Mateusz, what is your perspective as well? Also, you're from this side about well building the community and well making education about space. In fact,
Yes, indeed, and I totally agree that the spin-off of space ISRU technologies will be great for and beneficial for Earth industry and technology, but also for the society. Besides creating efficient technical solutions, we are also creating a new space profession, actually, because for now, space engineers, space scientists, and the astronauts, the guys who actually go there, mission specialists or the pilots, there were the groups that were very highly trained, very elite, and not they are not large groups. They are niche professions. But if you think about extracting of minerals, even if it's in space, it's very well you can perceive this activity very well, because it's a very natural way to do for a human to gain resources. So one thing is the fact that in this way you can reach large communities, even those that have to, let's say, cease the extracting efforts on Earth due to environmental limitations, for instance. So you if you are a miner and you cannot mine anywhere and anymore on Earth, you can still try to pursue this new direction. This is about community building, and you do not need to go to space. You do not have to be, the astronaut's health and the astronaut's competence, because lots of this effort will be done robotically. It's the trick. How do you actually invent the extraction processes, the processing, and the utilization, even if it's done remotely and robotically? So it's about creating new jobs, actually. So on Earth, here on Earth, not only in space.
great. Yeah, and now I think that well, it's time to summarize our discussion, and well, it would be great if you can share your thoughts well about space mining. Well, if you can share it with us, well, how you see its future, and well, what kind of the most interesting things will happen well within next 5 or 10 years. So, well, Dorian, would you like to start?
Well, it's actually a little bit difficult to predict how everything will change. I mean, we see in the next 10 years, I guess most of the missions have already been planned out. But if we go a little bit further, it's difficult to see how technologies will evolve to meet the challenges. But all the challenges that we mentioned are also, they're if you flip the coin, they're also all the roadmaps for where we need innovation. So we'll see a lot of innovation there, and generally, I think, yeah, the space industry is very interesting because all the challenges that we face in the space industry are a reflection of the problems that we have on Earth. So we're forced to innovate and carry down lessons to Earth. For example, on Earth, we've decided that it's about enough removing fossil carbon from the ground for energy and then releasing into the atmosphere. Well, perfect. On the moon, there's no fossil carbon. So we'll be dependent on renewable energy from the beginning. We'll have a renewable energy infrastructure for rovers, for excavators, for everything. In terms of once we have people on the moon, it will be very difficult to provide abundance of water and abundance of food. So we will need to recycle water. We will need to recycle nitrogen. We'll need to recycle minerals with high efficiency. And of course, these are all the lessons that we are currently trying to implement in our terrestrial ecosystems or economies. So yeah, I think it's a great environment to learn, to force ourselves to innovate, to think creatively, and the space agency budgets, the government budgets, and all the private companies that are innovating in the space industry will have benefits that carry down to Earth. Mm-hmm. But what exactly are going to be all the solutions, it's a bit more difficult to say.
Yeah, and what is your idea about the future projects and the things which we'll see within next 5 or 10 years? I think that Alice, you can share with us as well. I think that you're quite busy with multiple projects. You're on mute, Alice.
Sorry, my dog was barking. I say that prophecy was given to fools, and I feel that predicting what is going to happen in the space industry is nearly as bad as predicting what's going to happen in Israeli politics. So, you just really never know what's gonna happen. We're going for the long run, and I think that one thing we are going to see is a lot of collaboration, because nobody can do this on their own. So already we have signed a contract between us and Eta Space, which is a company sitting in Florida, to do a joint project of demonstrating production of oxygen in high volume. And their part of it is liquidizing the oxygen and storing the oxygen. We cannot do this on our own. We have to have Eta Space together with us. And I think that what we're going to see in the next few years is more and more open source, more and more collaboration, more and more understanding of all the players in the space industry, that there's enough for everybody. Nobody has to hide anything. The more we share, the more we collaborate, the more success we'll all have in reaching the goal of doing something out there in space.
And Michał, what is your perspective, and what kind of projects can we expect in the nearest future?
Yeah, I truly think that those would be multidisciplinary projects. So as Dorian mentioned, probably Alice, but I haven't heard her, that you will combine a lot of disciplines to innovate. So it won't be only about the new technologies, but it will be about the collaboration of the whole communities and the networks from different domains. And this is really nice because the brightest ideas comes from different domains, and when different domains actually are talking to each other, the biggest innovations appears. I'm wondering how the future would look like in terms of the humanity and our possibility of collaboration. After all, I believe that looking at what's happening in the globe, having in mind all the wars and all the geopolitics which happens right now, I'm wondering how it will look with the new space and the new economics, or the lunar part of the economy, and the surface that will be the next, I think, wars for the surface of the moon between the parties, between the countries. So I hope that it will be you know that people and humankind will be in such a high position in terms of understanding each other that we'll be able to collaborate in that manner. But I'm looking at what's happening on the globe. I'm a little bit afraid that we'll move our mass from the Earth to the space.
And well, Dariusz, well, what is your perspective for the nearest future regarding the space project?
The resources on Earth are limited, and the resources in space are quite almost unlimited. So we need in the next years to develop the spectrometers. We need to develop build a new space company which could provide us more data about these resources, and also for example like helium or rare elements could be a source of the clean energy during this transformation currently, and it could also help here on Earth, but probably the first resources will help in the first humans on this planets. So that's it.
And well, Mateusz, and how do you see the future? Well, regarding space mining and well, space economy even.
Yes, it's really difficult to predict the future, but maybe I allow myself to see how I would like to see it. So in 5 years, I would really like to see the proof of concepts for ISRU, both on Earth and laboratory setups and on the moon in space, and at the same time a lot of investment into the mining data. Because before the whole mining campaigns are launched at full scale, we really need to have more knowledge about the optimum places where we actually can establish those settlements and those mining facilities. So that's my 5 years perspective.
Great, thank you. Well, I think that it was really interesting discussion about space mining and how this technology can be used directly in the terrestrial applications. So, well, thank you for all the speakers. It was a pleasure to talk with you. And, well, I think that, it's time to build the next chapter of our, human economy, in fact. Thank you all.